Relative motion in 2 dimensions at right angles. Sample problem. All right, let's break it down. The boat on the diagram given is heading due north as it crosses a wide river. The velocity of the boat is 10 kilometers an hour relative to the water. The river has a uniform velocity of 5 kilometers per hour due west due to current. Determine the boat's velocity relative to an observer on the riverbank. So we're going to draw the diagram. So what are the key points? The boat heading due north at a velocity of 10 kilometers an hour. The river has a velocity of 5.0 kilometers an hour east. Required to find the velocity of the boat relative to an observer. To make it easy for us, we're going to use the subscripts B for boat, W for water, and E for earth. So the velocity of the boat in water, 10 kilometers per hour north, and the boat relative to east is 5 kilometers an hour. Here's our riverbank. Here's our opposite riverbank. Here is the velocity of the boat in water. Here is the velocity of the boat in earth. And the final velocity is shown by the arrow connecting the the terminal point of the first velocity to the initial point in your final velocity. So what are we trying to find? We're trying to find the length of BE, and we're trying to find angle theta. And that's just our vote. Okay, so we have our diagram that involves vectors in 2 dimensions, so we can use components to solve it. The vectors form a right angle triangle, so we can go with the Pythagorean theorem to find the magnitude of the boat relative to the ground. Then we can use the inverse tan ratio to determine the direction. So when we substitute everything in, we will get the square root of 10 kilometers per hour squared plus 5 kilometers per hour squared, which works out to be 11.2 kilometers per hour. The tan of theta is the opposite, which is WE, over adjacent, which is BW. So 5 divided by 10 works out to be 26.6 kilometers an hour, which is our solution. So our observation, the velocity of the boat relative to an observer on the riverbank is 11.2 kilometers an hour, north 26.6 degrees east. And that is our conclusion. And now let's try the example in the assignment.